So here we are. This is homework number, 6, right? We're going to finish 6, and the hope is also 7. We're kind of like hitting the accelerator at this point, because these are quick sections for you. I think these problems will be quick and easy. So I'm going to move over them fast, 6 and 7. But you let me know if I'm going too fast. Otherwise, I'll just keep moving right on through here. And then I'm going to slow down. I'm going to try to do 6 and 7 today. Is that right? Finish 6 and do 7, and do 8 and 9 Monday. Bless you. 8 and 9 Monday, and then I'm going to slow way down and do homework 10 for 2 whole meetings. And instead of 2 sections in one, I'll do 2 days for one. I'm going to slow way down for 10 and 11 because they're harder. So we'll see. We'll see how we do. All right. So remember how to do this multiplication distribution thing from your algebra days? I assume this is pretty easy for you. Boom and boom, right? Just whatever's on the outside just multiplies both those. So x times t plus x times o. Math Excel is pretty picky, or my math lab is pretty picky about the case, uppercase, lowercase thing. So it'll tell you wrong if you don't give it the right case. So make sure you give it the right case on those. You don't want to waste your time fiddling around with Math Excel when you try that one. Try part C there. Go ahead and do what you can to simplify that. See what you remember from your algebra days. Were your algebra days good days? I always ask that with kind of a smirk. I don't know, sometimes they were. My algebra days were good days, but my geometry days were not when I was in high school. My algebra teacher was fabulous. He's probably part of why I'm majored in math and teacher today, but my geometry teacher wasn't. Algebra teacher was great, super serious, very helpful. I don't know if you think I'm serious about math, but he was like so serious about math. Like it was life, you know. But then my geometry teacher didn't care a hoot. He would just go to the board in high school, like for 5 minutes, kind of fiddle around on the board. And then he'd say, figure it out, read the book, kids. And he'd sit down at his desk for the other 50 minutes of the period. So I didn't learn a lot of geometry. All right, anyway, I had good algebra experience, not a good geometry experience. All right, let's distribute on through. So that's A times B plus A times C. And then that minus AC at the back is still just hanging out there for a second. Good so far? And then what happens? It's just cancel, huh? Which I kind of missed, but you know what I mean. So the answer is just AB. Good deal? Remember that kind of stuff from your algebra days? Your glorious algebra days? Preempt you with a question. Let's do, Yeah, do that one. Do that, so it'll be an example or a do here. So try that. Do that one first real quick. Work that one out. I think you remember how to do that one. I imagine you do. All right, so we ready? What's the answer? Let me give 2 options. Option A, 20. Option B, 14. Option C, none of the above. Well, we've got to have none of the above. So what's the story? 14? Not 20? See how we would get 20. If we added 2 and 3, got 5 times 4 would be 20. But if instead we multiply 3 times 4, 12, add 2, 14. So which one's right? 14. You guys seem pretty committed to 14. Why? Order of operations. Yes. What is the order of operations? PEMDAS. Anybody still say, please excuse my dear Aunt Sally? Is that getting too old-fashioned? All right. Please excuse my dear Aunt Sally. Yeah. That's the order of operations. Sounds like you know it. That's correct. Order of operations. So in other words, it's not just left to right, is it? It's not just left to right. It's certain operations are done before other operations, I think you know. So if you look at the 3, he has 2 demands on his life, right? He's being asked to add to something, add to the 2. He's being asked to multiply by the 4. So which one will he do first? He'll multiply, because MD, multiply, that stands for multiplying and dividing, is before AS, adding and subtracting. What does the P stand for? Parentheses. Yeah, specifically, I don't know if you know, it's not just any old parentheses anywhere. It's problems inside parentheses. And E stands for? Exponents. Exponents. Yeah. Okay, now what do I mean? I'm kind of making a big deal out of that. Oh, and by the way, notice how I put, sometimes I'll see people write the PEMDAS like this. They'll write, whoops, I skipped the E. They'll write it all down, M-D-A-S. Rather than, see how I put M and D on the same line and A and S on the same line? That matters. Because M and D are the same level of priority. Multiplying and dividing are equal priority. If you write it like this, you're saying M is above D. It's not. They're the same level. So what does that mean they're the same level? That means you do whichever one comes first, left to right. When two things are the same, then left to right comes into play. So for example, here's where this would matter. Let me give you an example of a problem. What if you had 12 divided by 2 times 4? Now you see I could get two different answers there. If I really thought it was like this and multiplying was above dividing, it's not, then I would multiply first. Oh, here, let me just make that 3 for easier numbers. I would multiply first, that'd be 6, and then 12 divided by 6 would be 2. But that's not the real answer. Because dividing is not really below multiplying. It's the same level as multiplying. M and D are on the same level. That's why I write it that way, which means what? They're equal, so you just go left to right. So you actually do the dividing first. 12 divided by 2 would be 6, times 3, 18. Very different answer, huh? Make sense? So make sure you know, for PEMDAS, multiplying and dividing are the same level, and so we're adding and subtracting. Same level as each other. Now, what about that other comment I made about the P is not just any old parentheses anywhere, but it's problems in parentheses. Here's what I mean by that. If you have something like 3 plus 2 minus 1, 5, you all know that you would do the parentheses first, and that's totally right. You would do that first, right? You would resolve 2 minus 1 would just become 1, and then you would multiply 5 times 1, right? Multiplying is, before the adding, and then 18. That's correct. Totally right. I don't think anybody would do that one wrong. Here's where people get a little tricked. Let's see if I can think of it. Or a good way to do it. Yeah, how about again? 10 divided by... Yeah, there we go. That's a good one. I like what I've made. All right. So, let me let you try that one. Try that one on your own with whatever you think is true about PEMDAS. Yeah? Oh, that was craziness, wasn't it? Yeah. I was testing you. Well done. It's really 5. Thank you. I'm just kidding. I was just goofy math there. Thanks. All right. Try that next one. So do whatever you think PEMDAS says, and then we'll talk about it. You'll get more out of it if you try something rather than me just say it's this, it's that. It'll be more meaningful for you if you do it. Math is really, learning math. If y'all are going to become math teachers, part of what you'll teach anyway will be math. Math is learned really by doing problems. There's just it's not mainly learned by lecture or somebody talking at you or those kind of things. If you're going to teach kids math, teach anybody math, problem. I mean, it's just doing problems. That's where learning comes from. I experienced that just this morning with my own. We homeschool our kiddos, and my son's doing trig right now, and anyway, my 15-year-old, and he was. I was like, so John, what's this relationship? What's that relationship? And he was saying different things. Oh yeah, Dad, I know that. I know that. I know that. And I said, okay, really? Here you go. And I wrote out a problem and handed it to him. He looked at it for about a minute, and he goes, okay, I don't know that. Right? There's talking, and then there's doing, and then really there's no substitute for doing problems. And then I showed him. Then he learned. I said, see, when you have this, you do that. So when you're teaching anybody's problem. So what's the deal here? What do we do first? Let's learn from a problem. That's how we learn math, is from a problem. So what do we do first? Should I multiply first because parentheses are first? No. That's not what it means, and that's what I want to explain to you. That's not what it means in the PEMDAS when it puts the P at the top. It doesn't mean anywhere you see parentheses at any time, always go there first and do that thing first. No. It means if there's a problem, like this, if there's something not yet finished inside the parentheses, wrap them up first. That's what it means. But at this point, that's just multiplication. This parenthesis, there's no problem to be finished in there. That's just times, isn't it? That's just a different way to say multiply. So does that make sense? So the P in the PEMDAS doesn't mean any parentheses anywhere, always go there first. It means if there's a problem in parentheses. And most people don't know that. They just say parenthesis. But what about parentheses? Again, there's the difference between just saying math and doing math. It's always about doing. So what does that mean? Well, that means this is just multiplication. This is division. How do they compare? Please excuse my dear Aunt Sally. M and D are the same level. So I'm going to do the divide first. If two things are the same level, you just go left to right. So I'm going to divide first. 10 divided by 2, 5, and then I'll multiply afterwards. 25 is the right answer. Rather than the other way, I'd get 10 divided by 10, I get 1, huh? Very different. Did I do this one right? I think I did mess up this time. All right, good? Making sense? So that's the PEMDAS. Okay, so with that in mind, let's look at their little questions will be easy now. All right, so what they want you to do, thinking about PEMDAS and all that kind of stuff, A, B, C, D, let's just start with A. They want us to, on A, put parentheses where they should go to make A true statement. Or maybe they're not needed at all. Look up there at A. 4 plus 3 times 4 equals 28. If we leave it without any parentheses, is it true right now? It'd be 4 plus 12, 16, not 28. It's not true right now. Remember, you got to multiply first, right? Unless you bring in some parentheses. So right now it's not true. They want me to make it true, so it clearly needs to have some parentheses. Where do they go? Yeah, can you see it? That's true now, huh? So now you would do that problem in the parentheses first. 7 times 4, 28. Good. All right. How about B? Same thing. That's, I don't know if you can see it. That's, oh, you can. That's a divide, and then that was plus on that. So make it true. Maybe it already is true. If it's not, put in parentheses to make it true. Where do they go? So is it true right now? 12 divided by 4 would be 3 plus... Oh, it's true right now. We don't need any parentheses. Yes, I didn't realize that. It's true right now, isn't it? Because 12 divided by 4, you divide first, right? Is 3, then add the 1. It's already true. It doesn't need any parentheses at all. Division happens before adding, subtracting. The main thing to remember with the PEMDAS is adding, subtracting is last. That's the main thing to remember. Adding, subtracting is the bottom. So, yeah, it's already good, huh? You could put parentheses, and this would also be true, but they're not really needed. So we can just leave it as it is. It's good as it stands. Okay, how about C? C, that's a plus sign, and a divide. See if you can make that true. Or maybe it already is true. Does it need parentheses? Yeah. Definitely, right? Because right now it'd be what? 9 plus 9 divided by 6. I don't know, that's some decimal. It's not going to equal 3. So it needs parentheses. Where do they go? Yeah, that whole group added, huh? Because that'd be 9 and 9. That'd be 18. Problem in the parentheses first. 18 divided by 6, 3. Good? How about D? Try out D. I don't know if you can see it well, but the middle one is a divide. The other two are plus. Maybe it doesn't need parentheses. Maybe it does. You decide. So try working it out first without parentheses. If it's right, then you don't need parentheses. So if we were to work it out first, D, without parentheses, what would you do first? Yeah, the divide, right? Because that's higher priority. Adding, subtracting, adding is last. So this would be 3, and then we'd bring down the 5 and the 4. That is 12. So it's good. We don't need any parentheses. It's good as it stands. Good with all those? Questions on order? What is the name in math for backwards distribution? That's what I want to do here. I want to take this, let's do part A. XY plus Y squared. And I want to figure out, hey, before it got to there, it was something with parentheses, with a plus sign in the middle. There was something out here, and there was something here, and there was something here, and this thing went boom and multiplied, and it became these two things. Let's figure out what it was before it was distributed. So let me make it a little bigger here. So there was something out here, something here, and something here. So what was it? How do you figure out what was out here first? Yeah, what did they both have? Yeah, what's this called that we're doing? This is called factoring. I don't know if you caught that when you're going through those glorious algebra days. But that's what factoring is. Sorry, I'm spitting on the front row. I do that every night. Don't look Sorry. Factoring is unmultiplying. That's what it is. It's reverse multiplying. So that's, you might wonder, why would you do such a strange thing, unmultiply? But it's actually helpful in higher math science all the time. So anyway, so we're going to look at these two and we're going to say, what's in common? What do they both have? They have a y. We call that the GCF. Right, we're going to get into that next week like crazy. We're going to go crazy with GCF and LCM, so I'll leave it for then. But that's the greatest common factor. Why it's called greatest, why it's called common. Like I said, we'll go crazy with it next week. But for now, that's what's in common. Take out the y. What goes on the inside? Then y times what would go back to xy. Just the x. And y times what would go back to y squared. Just the y. Done. That's called factoring. We unmultiplied it, didn't we? We found out what it was before it was multiplied. That's what factoring is. So that's A. How about B here? Can you do B? Let me bring it down. B is x, y plus x. Can you figure out that one? Give you a second. What was outside the parentheses? All right. So what do they? You always put outside what they have in common. What do they have in common? X, clearly x. So x. Now x times what? You just think multiply backwards. That's all factoring is. Multiply backwards. X times what will go back to xy? Y. And x times what will go back to just plain x? 1. We all good with that? A lot of times when I'm teaching algebra, I get that question. Where'd the 1 come from, Ms. Taryn? It's because that's what works, huh? X times 1 would go back to x, wouldn't it? All right. One more. How about this one? Same kind of thing. Parenthesis. 2 things on the inside. 1 thing on the outside. Take out what's in common. Greatest common factor. So you're asking yourself, what do they both have in common? Like, do they both have an A? Yeah. Do they both have A squared? No, this guy, the right one, only has regular A. So they both have a regular A. That's as much as they have A-wise. Do they both have a B? Yeah, they both have a B. Do they both have B squared? No, this guy's only got regular B. So what they have in... See, that's the greatest amount they have in common. Does that make sense? It's the greatest amount. But I actually took the lower power on A and the lower power on B. It's kind of weird, isn't it? Greatest common factor involves lowest powers. Like I said, next week we're going to go crazy on all that. Make sure that's super clear in your mind. But that's true. What they have in common is what the lesser... Like if I have 3 coins and Josh has 4 coins, what do we have in common? Well, 3 coins. We both have 3 coins. We don't both have 4. Josh has 4. I only have 3. Right? So the lower number is the greatest amount you have in common. That's true. So the greatest amount they have in common is just AB. What goes on the inside? AB times what would go back to A squared B? A, because remember from algebra, the invisible 1 powers add, and then AB times B, huh? And there we go. Remember all that? Factoring? Bring back happy memories from algebra days? So, you remember those names from Wednesday? Look at A there. What's going on in A? There's the suggestion, commutative, associative, identity property, multiplication, distributive property, multiplication, zero multiplication property. What do you think? Remember those sort of a little bit from Wednesday? Anybody? It's the associative one. Yeah, that's the associative. Because right? Here the parentheses are associating the 7 and 9, and here they're associating the first two. So it's whether you associate the first two or the last two. Right? Commutative, the other main one, is where you switch the order. They didn't switch the order. That's what they're doing on B. See on B? See on B, it's commutative. See the difference? A is associative. B is commutative. See the difference? Right? In B, they swapped the order, right? It was 6, 7, 9, now it's 6, 9, 7. So commute is like driving back and forth to work. You commute, you go back and forth, you switch the order. Associative is you just associate a different two together. You don't change any orders. How about C? What did they do on C? Is it associative? Let's ask that first off. Is it associative on C? Well, which two are they associating together? 7 and 9 and 7 and 9 didn't change. They did not associate a different two, so they didn't use the associative property. The associative property says you can associate a different two and the answer will still be the same. That's what it says, right? Just like commutative says you can switch the order and the answer will still be the same. 2 times 3, 2 times 2, it's still 6 either way you do it. So all these rules say you can do this, you can do that, and the answer will still be the same. So the associative says you can associate these two or those two. Well, that's not what they're doing. It's because it's the same. They did not change the association. Did they change the order? Yes, they did. The 6 was on the left. Now the 6 is on the right. They moved the 6 to the other side of the parentheses, didn't they? That's commutative again, isn't it? It's just a little bigger version. Do you see that? That's order change. Order change. That's what commutative is. Order change. How about D? Yeah, that's the one times anything as itself. They call that the, there it is, the identity property of multiplication. Identity property. So, meaning one is called, I don't know if you ever know it's called that. They'll probably call it that in your elementary math books. The identity element, meaning it gives you back identically whatever you multiply it by, right? Like 1 times 7 just gives you back 7. It's like a mirror, right? You look in the mirror, you see an identical image of yourself, right? It's a reflection. That's what they say one is. One is the multiplicative identity element. It gives you back identically what you multiply by. Next one. Yeah. Well, it is distributive in a sense, but it's not this kind. It's not distributive property multiplication over addition, because there's no adding. So they put that in there particularly, because otherwise, yeah, you'd be totally right. Because, yeah, it's like they have the parentheses and they're gone, which is distribution, but not there wasn't addition. So that's why they said that. Yeah, good question. How about E? What's going on with E? Zero multiplication, right? It's multiplied by 0. Anything times 0 is 0. It's the 0 one. Finally, F. What's going on in F? They distributed. Yeah, did y'all see that? They distributed. It's kind of a big fancy distribution. Can you see it? What might help you is think of this 6 plus 7 as a big blue blob. Just think of it that way for a minute. Big blue blob, big blue blob. Maybe it's a big W or something. Because I think it's confusing. Because here's the deal in math. You know what math is? Essence. I guess we should be talking about that. And I'll say it again in future days. But math essentially is patterns. That is really it. Fundamentally, what is math? The study of patterns. And so, for example, the distribution property says the following pattern. If you have anything in the front and like two things on the inside, right? Isn't this what the distribution property says? You can take that one thing in the front and go boom, and it'll multiply that front thing, and it'll multiply that other thing, right? That's the distribution property. It's a pattern. You want to look at it and not get hung up so much on the W or the A or the B. Not get hung up so much on the form of things, but see the pattern that's existing there. In other words, that's why it's helpful a lot of times if you teach math to show it in different ways. And that'll be you all as you teach. Show it like, sometimes I show triangles and stuff. And I even say I do this for my algebra students sometimes, advanced algebra students, like pre-calc students. I always feel like I need to apologize. I'm not treating you like a kindergartner, but it'll help you see the pattern when we do a really hard thing in pre-calculus. And I'll say, well, what's the pattern there? Because they're having trouble seeing something. And I'll go, think back what the pattern is. Boom, boom, right? Triangle, square, triangle, circle. Whatever. With a W, with an A and a B, triangle, circle, whatever. It's just a pattern, isn't it? That's the distribution pattern. Well, do you see that that's what they're doing here? They've just made it bigger. See, that's the trick in math. You take a basic pattern and then they blow it up. They make it bigger. They put in extra parentheses and stuff. And then it's hard to see it anymore. And that's, bless you, that's the whole growing ability of math. That's what you want to grow in as you study math. You want to help kids grow in, is their ability to recognize, see, predict, describe patterns. That's math ability. And that's what helps you do. And that's why math is useful to more than just, it's all kinds of fields. Lawyers do and doctors do. They look for patterns and diseases and laws and, on and on you go. So let me show you what I mean. Why is that a pattern? What's confusing is that 6 plus 7. Just imagine that whole 6 plus 7 there is, again, a W. What if I just gave you W outside of 1 plus 9, okay? Now, everywhere I see 6 plus 7, I'm going to call it W to help your eye see the pattern. See what's going on there then? That W went to the 1, and that W, right, went to the 9. See its distribution? Instead of the W, though, it's a big old parenthesis 6 plus 7. Whatever. Same thing. Make it giant, make it small, same pattern. Do you see it now? Do you see that that's all they did? It's the same pattern as distribution. All right, we better move on then. Let's see, number 16. 48 divided by 6 is 8. They ask us to make a related multiplication sentence. So 48 divided by 6 is 8. That you know. What is the same thing said with multiplication? Same truth with multiplication. Yeah, 6 times 8 is 48. You got it. So again, they're just showing the connection between dividing and multiplying. Remember, we talked about that last time, right? How all the operations are related, and especially they all go back to adding. Number 17. In each of the following, tell which computation should be done last. So, can you see number 1 there? Which one should be done last in part 1? Yeah, subtract 18, right? Because adding, subtracting is always last. Remember the PEMDAS, adding, subtracting is last. Good. How about this one? Which thing, this one's more tricky. Which thing would you actually do last if you were to work that out? Do you see that you would do the divide? Maybe we should work it out. Maybe that helped. What would you do? I think if you did it, you would know, I think. What's this? 10 minus, you would do the parentheses first, right? 10 minus 7. 3 plus 5 is 8. Divide those. That reminds me, by the way, really quick. All right. So so you would add those up, add, subtract first, get 8, and you would divide last, wouldn't you? So the dividing is last on that. So the last thing you would do is the divide. Number 3. What would we do last there? What would we do? You'd actually add, wouldn't you? Because you do those 2 parenthesis problems first, and then you would add at the end. So the last thing you would do would be to add. That's kind of funny. All right, and what would be the last thing you would do on number 4? You would add, because, well, yeah, that's not funny. That's normal. Adding is normally, yeah, that's right. Okay, yeah, good. All right.